marketing. Yeah. So anyways, and so the tool that we're going to release is called Office, and it's actually like a Office it's a visualization tool, and it parses any standard OLE file, and it has the capability of defragging the file system for you so that you can parse it manually. So I'm going to demo that. Hopefully it works. Let's do this one. So here, like like on the left side, you see the root entry. The root entry, you can see like PowerPoint document. This is the main one, and you click on it, just selects it, and then this one is not too fragmented, but you can go to Tools, and you can defrag it, and then you can save the file. And the reason why this is useful, you might think, well, what the hell? I can just do this in Python, right? The reason why this is useful is because if you want to write a parser from scratch in your hex editor, you want to treat the hex editor doesn't have a concept of streams, right? So it just notes at consecutive bytes. So, but if you fragment the file, then the consecutive bytes means I'm going to be part of the same record. So you can parse it that way. So that's why this is useful. So we'll probably release this. We don't know when it's going to appear, but we'll release it to the public, probably on our blog or something like that. Did somebody ask, is it going to be open source or something? Oh. Yeah. Yeah. And so, yeah. We probably won't release the source code for it because it's pretty simple, and most people could probably decompile it anyway, so it would be like an offense to do that. Yeah. No joke. I mean, this is .NET, right? So now I'm going to show you an exploit demo. I'm not going to show a real one because I guess I'm not supposed to. But this is a simulation of what a real exploit will look like. So they typically come in email, and so they'll send it to the person. In this case, I'm going to use myself as the victim, and the attacker is going to be like the CCC staff. So most people, they'll probably know that I'm attending it because you can read it on the website, and they'll send an email saying, oh, hey, Fukami Fleet says that you're coming here, so here's a list of things that you should see. Nice, we'll see you there. So obviously, I'll probably click on this stuff because it makes sense, and so I'm going to click on it and see what happens. So it's going to be like, normally I would have Outlook set up, but that's too much work and it's not really necessary. So I'm just going to double click on this. And here, bam, right? You notice? Here you notice it opens a clean document with the name of various, I guess, popular tourist spots. I don't really know what these are, by the way. And then it launches calc.exe. This is obviously a demo. In real life, they'll drop a typical rootkit or some type of Trojan, and you obviously you won't see it. And to a normal user, I ran this in a VM, but to a normal user, it'll be like very fast. If you're on a real machine, you won't even see it. If you notice, you saw it quitting and then restarting, right? That's because the VM is slow. So, but in real life, you won't even notice it. So, anyway, so that's how it works. That's what it looks like. So, yeah. And I mean, even though that was a fake example, this type of attack is quite common. For example, I've seen attacks where people will send an email to somebody and say, hey, check out my vacation pictures. And then they'll attach typically a PowerPoint or a Word document which will include pictures, and they'll open it up. So this is not far from reality. All right, so the defensive mechanisms, how do you protect yourselves? Always have the latest security updates, I guess. It's kind of obvious. One thing I should bring up is most consumers probably won't be affected by this because consumers have, they turn on Windows Update, so you get the patches automatically. So most of the time, you'll be okay. But sometimes large corporations, not everybody can patch on the same day, right? So, they don't always have the latest patches, so they get owned. So, The other option is if you have Office 2003, just like you install Service Pack 3, which is we released like in December or something like that. It's free, and basically SP3 is the result of a major security push. We fixed a lot of bugs there. And one fact is, if you have Office 2003 SP3, then you would not be vulnerable to any of the quote-unquote zero-day exploits that was acknowledged in the public. In fact, I've never seen one that affects Office 2003 SP3. We have seen bugs that affect 2K3 SP3, but I haven't seen like real exploits that work on it. So if you have Office 2003, just install SP3. The next one is can you use Moleyes. Moleyes was actually written to fix these target attacks, but not everybody can use them. It requires at least Office 2003. And the way it works is quite simple. It converts the binary file format to the new XML file format, and then reopens it using the XML part, the Office 2007 parser. So there's no more bugs there. So yeah, yeah. And this is why when you download Moleyes, they'll tell you you need to download the Office 2007 compatibility pack, and that's the reason why. And if you use Office 2003 SP3 and Moleyes together, I would go to say that it would mitigate many of the Office. Well, I want to say all, but never say never, right? So, but it's quite effective. And this is one of the main reasons why we list Moleyes as a workaround on a lot of the Office bugs that we patch, on the Patch Tuesday. And the last one, use Office 2007. Yeah. So I won't say too much about that. And to be fair, I want to say that it's not just Office that's being exploited. Adobe PDF, it's also quite common. In fact, in the last couple of months, PDF target attacks using PDFs as attachment is quite popular, and it's actually on the increase. I wonder why, but yeah. All right. So we're going to the exploit structures. Now I'll show you the file format, a demo of what the exploit looks like when you get owned, and how to defend yourself. Now we're going to the analysis part. So the exploit is actually quite simple. It's nothing out of the ordinary because it's just another most bugs. It's not like a bug in Office is different from a bug in I don't know, Win32K or something. It's mostly like memory corruption. Sometimes Office will actually read a number from the file and then use that to calculate some pointers, and without checking that number. So you can change the number, do whatever you want with it, and you ruin Office or something. I don't know. Anyway, so the basic structure is you'll have shellcode, which is all exploits have them. And then you have a malware component, which is attached to typically the end of the document. Sometimes it can be in the middle of the document. It varies. And then you have a clean document, which is what the victim sees when the exploit runs. So in this case, in the case that I have, the clean document was the document that had those list of tourist spots. And I'm going to go into the techniques. The techniques are actually not too special, but some parts are unique. So this is a picture, an abstract picture of what it looks like. So in the top, you have an OLSS header, which all OLSS file has. And then you have some Office records. And then you'll have some shellcode. And then maybe you have some more Office records. And then towards the end, you have a piece of Trojan or malware. In this case, I only show one picture, only one Trojan or malware. But in some cases, you can have up to two. They can have like 2 or 3. I don't know why, but they're multiple. And then towards the end is usually a clean document. But then, of course, you can always swap these things around. They can be variations. But the important thing is, it's all delivered in one package. It's one document. Everything is inside. They don't have to phone home to download a Trojan or whatever. So it's very convenient. And also it bypasses AV detection, because the AV file, they're not going to scan the Office document. If they see an exe field and a trigger, they're not going to do that. So, because sometimes people do insert these things there for legitimate reasons. So. Okay, so the techniques they use. The shellcode is pretty simple. You use standard get EIP, so they'll do jump call pop, or use the FNSTNV instruction. They'll have custom encoders. Sometimes the shellcode won't be encoded, so you can actually spot it pretty easily. But 99% of the time, it'll be encrypted. So you'll just have like, a decoded stuff, which is probably maybe about 20, 30 bytes, and then the rest is all like, obfuscated / encrypted or whatever. And it uses this very standard Win32 shellcode, pub retrieval to get the base address of current 32, because we don't do syscall through int80 like we do in FreeBSD or Linux. And then the last two characteristics are fairly unique. One is file handle brute force and application relaunch. File handle brute force, I'll explain next. Application relaunch is what happens when they call exit process on the exploited process, and then they call winexec to reopen it, and that's what you saw when I double clicked on it. You saw if it popped up and then exit and then reopen again. That's the application relaunch. Sometimes it crashes, but still works. But nowadays the attackers are pretty smart people, so it doesn't crash anymore. So why do they need to use file handle brute force? The reason why is the exploit needs to find itself in memory, and by this I mean not get EIP, but to find the physical the physical content of the file. They need to find that. And in order to do that, you need to get a file handle to it. So the other way they can do it, they can scan the entire process space and look for Sentinel values, and then say, oh, once I see value OX123, oh, I know that's my file, and I'll start parsing. But in reality, that doesn't work because the entire process space is very big, and you don't want your exploit to take too long because people will get impatient. They'll just close it. So so this file handle brute force method is very simple and very short to implement in assembly. It's probably about maybe 6 instructions or so in assembly. And the way that's all I do is they start from file handle 0 and they call get file size on it, and then the get file size will return a value, and then they compare that value to a known value, because they already know what the exploit file size is like. So once they know the file size and they compare it, and you get a file handle back and the file size is the same, there's a high the chance of it's probably the same files that they use. So, and inside that file, they already know exactly where the offset of the Trojan, the offset of the clean files, so they can just fseek to it and extract it. So anyways, that's how it works. So this is a summary of the exploit structure. There can be variations. I just want to make sure that I say that. So the shellcode decodes itself, and it jumps to a decrypted region. It builds up a list of function pointers that it will need later. For example, set file pointer, which is the equivalent of fseek or lseek, and then read file for reading the file, write file for obviously writing a file, and then closing the file handle, and then winexec to execute the file. I mean to execute winword or excel.exe or whatever. And then exit process, which is to kill itself. Sometimes we use exit thread, but And then once it built up that table of function pointers, it will do a file handle brute force, and then once it finds itself, it seeks to the offset, and then they already know ahead of time how big the Trojan is, so they just read that much and then they write to disk. And typically they'll extract it to the temp folder, and then they run it. Some of the evidence you can see, if you check your temp folder and you see weird exe files or whatever there, that could be it. Yeah. And then it runs a Trojan, and then it relaunches the app to open the clean document and exits the current process. And that's it. And sometimes what they'll do is they'll actually have the Trojan, they'll have the clean document inside the Trojan. So, yeah. All right, so So now we go into the tools. What kind of tools do you need to analyze these things? Obviously, these are not PE files, so you can't use a debugger to deal with it. So the tools you'll need is actually very simple. All you need is a hex editor. You can use Hue or Hexer, and a disassembler. You can use also Hue or IDA. And if you want to use a debugger, WinDBG is pretty good. You can use OllyDBG as well. And the objective, when you analyze these things, what you want to do is, first you want to identify the shellcode, and then you want to understand what it does. Most of the time, you really don't need to understand every single aspect of the shellcode, because sometimes you get thousands of these samples, and you don't want to go through and understand every single one of them. Most of them are the same anyways. So, and then you extract the malicious component, typically extracting the Trojan. And if UNIDS